and its applications. So, I welcome you again to this short course on aerospace engineering. Thank you. As you can see, the evolution of launch vehicles in US, all it started from the ballistic missiles type launch vehicles, whereas these ballistic missiles they travel up into the space up to certain altitude and then return back to hit the target on the earth, whereas in 1960s the Saturn rocket launch vehicle came up, and as you can see the Saturn rocket was being used in various launch vehicles, be it Delta rocket, Atlas launch vehicles. In 80s, the era of space shuttle began, and you have seen the launches as well as re-entry of space shuttle. Out of the space shuttle, there was one unfortunate accident of Challenger launch vehicle, the spacecraft, the space shuttle during its launch time. Whereas we know one more unfortunate accident during re-entry into Earth's atmosphere of Columbia Space Shuttle, in which we lost our dear Kalpana Chawla, Indian astronaut of Indian origin. Then in late 90s, the era of expandable launch vehicles started. So we will see in further slides what is the meaning of expandable launch vehicles. And after certain gap, again the expandable launch vehicles from 2010 onward started coming up, especially with private industries like SpaceX making Falcon 9 rocket. This is the spectrum of Indian launch vehicles starting from SLV-3, which is satellite launch vehicle, which was upgraded as augmented satellite launch vehicle. You can see two more rockets as booster rockets strapped around. And then came PSLV class of vehicles with further lifting capacity of the launch vehicles. In the most recent version of these launch vehicles we have in India GSLV and GSLV Mark III DCX, which is made by McDonnell Douglas company, and then on top left we have X-33, which is Lockheed Martin Venture Star. Private industries have come, and not to forget SpaceX company, very famous private company, has come up with expandable launch vehicle which can partially be recovered as a reusable launch vehicle by returning the first stages for use. So similarly, Blue Origin New Shepard rocket became the first proven vertical takeoff, vertical landing rocket in year 2015, November 23rd, which can reach in space up to 100 kilometers. So as you can see, Falcon 9 rocket in the image. So these rockets, they can perform vertical landing, and in some of the rockets parachute can be used to land vertically either at sea, or if there are small rockets they can be vertically landed using parachute on the land. The rocket could be used to soft land on the vehicle on the ground from the subsonic speed reached at low altitude. So they can be recovered, vertically landed onto the vehicle itself. So this requires around 10% of the landing weight of the vehicle to be propellant. Alternatively, autogyro or helicopter rotor can be used to recover the landing weight of the motors. So here you can see after liftoff, acceleration and apogee, there is a parachute ejection from the top, and this parachute helps in recovery of this. We also have retro-propulsion or back propulsion landing, where retro-propulsion means firing your rocket engines against your velocity in order to decelerate. So before landing you need to reduce your velocity quite a lot. So this deceleration can be achieved using retro rocket. The vehicle fires rockets towards the surface to slow the craft's descent velocity after the parachute had already brought it to the below speed of sound. So it is very expensive in the sense that the fuel required for the landing must be carried to the space, so which erodes the usable payload capacity of the launch vehicle. Coming to the launch vehicle fundamentals, the rocket mostly consists of, or the most of the space inside the launch vehicle mainly includes propellant tanks, which are combination of oxidizer and fuel. So you will have oxidizer tank in separate and fuel tank separate. So these two tanks are stored inside the rocket, mostly occupying most of the space, whereas the combustion chamber, after mixing of oxidizer and fuel, ejects gases through the nozzle, and because of these high velocity exhaust gases, the rocket propels into forward direction due to opposite thrust because of high speed. We can classify vehicles, especially the launch vehicles, into some major categories depending on their payload carrying capacity. So the launch vehicles up to carrying capacity of 0 to 2 tons of payload can be called a small lifting launch vehicle. A launch vehicle with carrying capacity of payload from 2 tons to 20 tons of the payload are called medium launch vehicles, whereas the payload carrying capacity between 20 to 50 tons. These launch vehicles are known as heavy lift launch vehicles. And finally, we have super heavy lift launch vehicles with carrying capacity more than 50 tons. Coming to the fundamentals of rocket motion. So we have rocket equation from the physics, which gives us velocity of the rocket from liftoff to the orbit where the payload has to be placed. So in order to place an object into the orbit, launch vehicle must increase its velocity until it is equal to the velocity required to maintain the orbit. So there is always orbit velocity in order to keep the vehicle or object or satellite into particular orbit. So the launch vehicle has to supply that much of orbit velocity. So from launch to that orbit velocity, whatever increase in velocity is required, that is a function of specific. Coming to the components of the launch vehicles, major components, you can see the payload which is to be carried by the launch vehicle, and then propellant which are stored inside fuel tank, and these fuel tanks occupy major space inside the launch vehicle, and then structural part which enhouses this fuel tank and the payload. So the payload mass and the propellant, and then we have structure mass. So you can see the propellant, fuel tank and engine mass, they come into the category of structure mass. Structural mass and the equipment mass also includes avionics and onboard computer mass. So these launch vehicles, they perform stages during its flight. So there are launch vehicles which perform single stage to orbit trajectory and reach the space orbit carrying small payload varying from 9 ton to 20 ton without losing any hardware to lower the orbit. Means the whole vehicle reaches to the orbit. Whereas in two stage to orbit, there are two independent vehicles which interaction while launching. So they are interconnected and attached they are attached to each other, and one of the stage detaches in between the launch vehicle when it is fully exhausted, its propellant is fully exhausted. Similarly, there are cross feed type staging that has two or three similar stages that are stacked side by side and burn in parallel. So you can see our PSLV launch vehicle has multiple rocket stacked around the core rocket as a cross feed, and they can carry heavy payload to space. Why staging is required in the launch vehicle? Because once the fuel is exhausted, so the empty fuel and oxidizer tank, they become dead weight to the overall vehicle and they don't no longer benefit, and we require energy to carry them. So at high flight path angle during the launch, the most of the energy is required to overcome the gravity, but at the later stages, when we have low flight path angle, that is, the spacecraft is aligned to the orbit in which the payload is to be placed. So, the most of the energy is required to produce the increase in velocity. So, thus, the segment of the launch vehicle which is now empty can be discharged or detached from the main launch vehicle. So these segments, when we use multiple segments and we detach once they are exhausted, the fuel tank and the oxidizer tank, they can be detached. So they are known as stages of launch vehicle. In case of multiple stage launch vehicle, as you can see, initially the payload is the desired payload, and this is for single stage launch vehicle. So you can see the propellant weight is propellant of both the tanks, and structure weight is overall structure in these tanks. But if you have multi-stage launch vehicle, then payload mass is the mass of the later stage as well as the payload itself, and the current stage propellant will be called as propellant mass, and then the structure of the launch vehicle which is in housing the current stage will be called as structural mass. So there are various types of staging which are used. So one is parallel staging, where you have multiple rockets stacked around. Then you have serial staging, where the multiple stages they are stacked one over the other. And then you have droppable engines which can be dropped during the trajectory. And then you have piggyback staging, where it's like space shuttles, they are attached in a similar manner with the. So these are the during the launch vehicle trajectory, there are some maneuvers or phases of the launch vehicle, starting from engine startup, then initial ascent, and then pitch over, coming to powered ascent, then burnout of stage 1. So as you can see, up to serial number 5, there is stage 1, which is giving thrust. After the burnout of stage 1, the staging is performed. The next stage, stage 2, powered ascent starts, and then powered burnout stage of stage 2 is executed once the fuel tank and propellants are exhausted. Finally, the launch vehicle enters into parking orbit, where payload is to be placed in a particular orbit. So as I have explained, there are stages which are performed during the launch vehicle trajectory, and this is example of a launch vehicle Pegasus. it is dropped from the aircraft itself. So it is air launch vehicle. So as you can see, after the drop from the aircraft at certain loss of altitude, stage 1 ignites, and after stage 1 the stage 2 ignition takes place, and after stage 2 you have the cost, the burnout of stage 2, and finally the ignition of stage 3 before the spacecraft or the payload moves in.
4, 3, 2, 1, 0, plus 1, plus 2, plus 3, plus 4, plus 5 seconds.
So, vehicle, GSLV MK III vehicle with the ignition of two solid strap-on boosters, S200, successfully lifted off from the second launch pad. Time is 20 minutes into the flight.
Plus 20 seconds.
जिसके समय अंतरिक्ष की तरफ उड़ान भरती है और गर्जना के साथ पर अग्रसर होता हुआ 40 सेकंड बीत चुके. So GSLV MK III going through the intense atmospheric phase of flight, which is very critical for the launch vehicle. And we just heard from the range operation director, the performance of the S200 solid strap-on booster is normal.
Plus 1 minute.
We are 60 seconds into the flight. Vehicle has climbed to an altitude of almost 15 kilometers. And as per the flight sequence, at 110 seconds, we should have the ignition of L110. Which will be followed by the separation of two solid strap-on boosters at 140 seconds. So right now we are at 86 seconds now. The altitude is around 27 kilometers and velocity is just 1 kilometer per second. And on the display plot, we have a very close match of the vehicle altitude, the pre-flight and the flight predictions.
जी हाँ, चूंकि आसमान बिल्कुल साफ है इसलिए दूर तक अंतरिक्ष में जाता.
Separation from the main vehicle. We are at 185 seconds into the flight. Altitude of almost 100 kilometers. The next flight event we are looking at is at 230 seconds when we'll have the separation of the payload fairing, which is the one which protects the spacecraft during the atmospheric phase. And on your screen, the parameters, the altitude, which indicates the height at which the launch vehicle is presently going through from the Earth, and the relative velocity of the launcher. So closed loop guidance algorithm has been initiated at 149 seconds. Performance of L110 is normal.
जो अगला क्षण है वो महत्वपूर्ण है पेलोड फेयरिंग से.
Similarly, there is a modern launch vehicle. They are able to return back to Earth's surface once they are used inside the trajectory. So this is called toss back booster trajectory. So in this, the main vehicle, the final stage or the further stages, they move into the planned trajectory, whereas the used stages, they perform maneuver which is called booster restart, toss back burn maneuver. So they are able to turn back with optimum trajectory with toss back constraint, and after